All right, welcome to our summer intern presentations for 2026. Our first presentation is Larry Zhao. He's going to talk about a system tray application for iRODS Ingest. Here.
Thank you, Daryl. So as mentioned, today I'll be talking about the system tray application for iRODS Ingest, which is a new application that Ryan, Trujan, and I have been working on for the past 3 months. So first, a little bit about me. I'm currently a sophomore at NC State studying computer engineering. I'm especially interested in autonomous robots and embedded systems. And in my free time, I enjoy playing volleyball and going out with friends. So first of all, why a system tray application? Why is this needed? So the current iRODS automated ingest is very powerful, but it can be very complicated and overwhelming for users to use. This is mostly due to it having an extensive amount of configuration options and a need to use the terminal. So what this means is that it becomes a little more awkward for it to be used in smaller applications or by people who aren't as familiar with working with a terminal. So our solution to this is to build a new cross-platform system tray application that allows less technical users to more easily get their files into iRODS. So this would include a simple, minimal set of configuration options, a GUI to allow the user to more easily interact with the app itself, and also have it run in the background while also being easily accessible through the system tray if the user ever needs to reopen it to mess around with the settings. So how the app works. The app is very simple to use. It only really takes 3 steps. So first, the user configures their iRODS session and which folders that they want it to monitor. And then after that, any files that get put and that get added into the folder are automatically detected and get uploaded into iRODS. Under the hood, this app has 3 major components. First, there's the GUI, which is made using PySide 6. There's the file detection aspect, which is done using Python Watchdog. And then there's the iRODS session handling and the uploading itself, which is handled by the Python iRODS client. In order to have persistence and settings that are saved between the app being closed and open again, we have 2 JSON files, which are the iRODS environment.json, which stores the session details, as well as the appstate.json, which stores all the settings and the different files we're monitoring, as well as the different settings within those files. So more under the hood stuff, this app is made up of 6 Python files. There's the main.py, which starts the program itself, config.py, which handles persistence, so storing things into our JSON files and making sure that what gets loaded in and out are correct and don't end up breaking the app. There's the iRODS worker.py, which handles the iRODS operations, so things such as putting the files in, the session handling, as well as creating new collections within iRODS. There's the monitor.py, which handles all the watchdog watches and all the instances. There's the UI.py, which handles the GUI. And then finally, there's the tray.py, which manages and controls the app itself. So after we made our initial little mockup, the features that I worked on mostly consisted of stuff that had to do with the actual file monitoring and yeah. So this includes stuff that includes such as the move, rename, delete detection, linking the source folders on the local computer with a target storage collection within iRODS, allowing folders to be monitored recursively, adding post-upload file operations, and regex file controls. So the first feature that I worked on was the move, rename, delete detection. So the thought process behind this was what would happen if a user decides to monitor a folder, but then later forgets about it, deletes it, moves it, or renames it. So the first idea I had for solving this issue was to just have the app ping the folder on a regular interval and just check if it still exists or not. However, I realized that this wouldn't allow it to automatically adjust if the user renames it. And I wanted this app to be more of a fire and forget so that even if the user renames it, the app will be able to automatically adjust to that and keep working as normal. So instead of having a check on a regular interval, I decided to implement a parent watchdog instance on top of the original watchdog instance for the folder itself. And so what this does is it allows the parent monitor to also check and see when the folder is renamed. And then with that, we can automatically adjust for it, so the user doesn't have to remove the folder and then re-add it again through the app. However, after implementing this, I found that it also had some unintended behaviors, such as for some reason, after we add the parent instance, the user is no longer able to delete the parent folder through the Windows File Explorer. So in the future, this issue likely have to be revisited and some changes might need to be made. The second feature that I worked on was linking the source and target. So each folder on that we decide to monitor has a source folder on the local computer and a target destination collection in iRODS. So that's where the files end up. So users are able to pick their source folder, which is the folder they want to monitor, and the target when they're adding folders in the app. So in the app, it looks a little like this. Users get this little text, this little folder picker to choose their source directory that they want to monitor, and then they can type in their target collection within iRODS. And then when they check their monitor folders, they can see this folder is going to this collection. All of these settings are stored within the appstate.json. So you can see we have one key for the source directory and one key for the target collection. The third feature that I worked on was recursive monitoring. So this was allowing folders to be monitored recursively. We found that recursive monitoring would be more intuitive for most users, and it also makes adding files more easy. So this means that if you have folders within your monitored folder, those will also get files within those folders will also get monitored and detected. And when they get uploaded into iRODS, it will automatically create matching subfolders that keep the same structure inside iRODS. Subfolders already being monitored through this feature can't be used as another source directory. So if you already have a folder that's being monitored because you're monitoring this parent, then you can't say, I want to monitor this folder because it's already being monitored. So in the app, this shows itself as a little checkbox. So when you're telling the app, I want to monitor this folder, you can check either monitor it recursively or non-recursively. And then it gets stored in the JSON file. The fourth feature that I worked on was the post-upload behavior. So what this means is that after a file is successfully uploaded into iRODS, the app can do the following to take care of it. So first it can delete, which is the default, and this just permanently deletes the file from the computer, and then the user will no longer be able to access it. Another option is to recycle it. So what this means is it sends it to the system's trash bin or recycling bin, and then let the system take care of it and delete it if the system gets, if storage gets too full, or after a certain amount of time has passes. The next option would be to move it. So you can move files that have been uploaded into another folder or another location on that computer. Of course, you can't move it into a monitor folder because that would result in a loop. So we just have to check against that. Yeah. And then the final option would be to keep it. So just have the file stay within that monitored folder and do nothing with it. The final feature that I worked on was regex filtering. So what this means is that users are allowed to add their own regular expressions to either allow or deny files that end up matching. And these patterns get stored in the JSON as usual. So in the GUI, you can see that users get this checkbox to enable regex filtering. They can either choose to have their regex patterns deny, so not allow certain files to be uploaded, or only allow files that match to be uploaded. They can upload their own regex and type it in, one pattern per line, and these patterns eventually get stored in apps.json as mentioned earlier. So key takeaways. So I got a lot from this internship in my opinion. The first thing that I really learned was how to build an app from scratch. So at the beginning, we did a whole bunch of researching on the different tools we wanted to use. After that, we did some brainstorming on how we wanted the GUI to look like and how we wanted the user to really experience the app, how we wanted it to flow. Once we had a general idea of how we wanted the app to work, we started doing some data modeling. So figuring out how we wanted this app to work in the back end. And then finally, we ended up making some mockups and eventually developed it into the app that we have today. My second key takeaway from this was Git school. So before this internship, I had always just pushed my changes directly into GitHub without any kind of restrictions. But after going through Git school and being in Git jail for about 2 months, I'm now a lot more familiar with the whole process of having to rebase my code, make a pull request, go through code review, and then finally having my changes approved to be merged. The third big thing that I took away was how to use AI to help me with my coding. I found that AI has definitely made me pay more attention to the actual design process rather than writing the code itself. And of course, while AI doesn't always write perfect code, it has definitely been a big positive impact on my internship and has allowed me to get things done faster and more efficiently. And fourth, but last and not least takeaway, is working in a team. So having morning meetings every day, stand-ups, has really helped me keep track of what other people are doing and also keep track of my own progress as well. Of course, there were some issues with communicating at the start where we weren't really sure what direction we were going into and what everyone wanted to work on. But once we actually got our code into iRODS contrib and we started making issues for the challenges we want to work on and claiming issues that we were working on and dividing up work, things became a lot more structured, a lot more clear, and it just became a whole lot easier to work as a team. And that's about it. Any questions?
Very good. Anybody have any questions? So I have a question. You probably had some expectations when you got here about what the summer would look like. How did we do? Was it what was the most surprising thing? What did you not expect? Knowing that you were probably going to show up and write some software.
Well, I definitely a lot of this was very new to me. I was expecting to learn a lot, and I think that I did end up learning a lot, especially with all the Git and the AI assisted programming, as I mentioned. And I think that overall it's been sort of what I've expected in some ways. Certainly the driving wasn't really what I expected because I only got my license a week before the internship. Having to drive 30 minutes to the office was a little bit rough. But yeah, I think it was a very fun time.
Excellent.
What, having worked on this project, is there anything that you would do differently now that you have reached the end and have an idea, you have some experience? Would your approach or anything change?
I think that one of the biggest things would be to make use of the GitHub issues in work structure at the beginning. Because at the start, we sort of just had one big Google Doc on all our planning and brainstorming. But then after that, when we actually started building things, we were very unstructured with it, and we just had us randomly just pushing the main all of a sudden in the repo, and we didn't really have any idea on what future work we really needed. So having these starting with issues earlier to keep track of what needed to be done and what each person was deciding to work on would have been a lot better.
And one other question: is there anything during this experience that you found to be more enjoyable than other parts? Was it just communicating ideas with team members, or writing the code, or interacting with the AI systems?
I really found that moment when you finally merge something into the thing and you can say close issue and it becomes purple. That was very satisfying to do. And I think that was probably the most fun part.
We love purple buttons. Very good. Oh, got one more.
So originally when you applied for this internship, it's kind of a two-part question. What drew you to iRODS or this specific internship that caught your interest? And then in the future, Renzi also offers tons of internships, summer internships, and based on your experience, would you apply again? Great question.
So what really drew me into this internship was the opportunity to really work on something that would actually might go on to become an actual existing application. So being able to work on a system tray application. I've never worked with system tray things before. I wanted to see what it was like. Building an app that actually runs and you can go and open it was really tempting for me. And the fact that this app might eventually in the future become something that people are actually using around the world was definitely something that drew me in. As for future openings within Rincy. It's more of a maybe right now because I'm also doing electrical and computer engineering. So I might end up going more into electrical aspects of engineering over software. But we'll just see where I am.
Very good. Thank you.